In this video, I'm going to talk about our AI project in machine learning class, semester 1, 2019, University of Toronto. First, I'm gonna explain what's the problem we are trying to solve, and then what are the data we are used for this model, how we train our data, and the prediction, and the result analysis. Without further ado, let's begin. Now, the problem we are going to solve classified into two different problems. First problem, we're gonna identify the speakers based on his voice, and the second problem will be identify the spoken digit. So, for example, let's say that you are calling the bank, and the bank, they are using AI system to identify your voice. It's kind of a biometric authentication, and also the system will able to identify the spoken digits. Let's say that you're saying your credit card number, then the system will be able to identify the numbers as well as make sure that you are the account owner. Now, the first part of the problem, which is a speaker recognition. This is our code uploaded into GitHub, and I'm gonna take you through the code to understand what we did exactly to solve this problem. Okay, now I'm gonna take you through the steps of the project. Step 1, we ingested the data and perform all cleaning and transformation tasks. Step 2, we choose the model and train the data. And step 3, prediction and result analysis. Now I'm gonna talk about the data. The data, we have sound tracks of 3 speakers. Each one will say each digit from 0 to 9 50 times. That's the data, so we have only sound files. And here is our code. We started this by extracting the wave features. Now there are 2 ways to do that. You can extract the wave feature into a picture and plot the spectrum, or you can extract the features, or they call it MFCC features, transform it into NumPy array, and then you can work on that array. And this is exactly what we did. We extract the MFCC features from the file, from the sound file, and upload it to our dataset, which is gonna be an Excel sheet dataset. A quick introduction about the MFCC library, if you don't know about it. It's middle frequency capistrel coefficient. Any sound generated by human is determined by the shape of their vocal tract, including tongue, teeth, etc. If this shape can be determined correctly, any sound produced can be accurately represented. The envelope of the time power spectrum of the speech signal is representative of the vocal tract and MFCC, which is nothing but the coefficients that make up the middle frequency accurately represents this envelope. There are like many coefficients on the lower dimension and in the higher dimension, but in this project we extracted the most important features, which is about like 25 features. So in this part, we as I said, we upload the data into dataset. Now I'm gonna take you through the code to see how we solve this problem. Identify the spoken digit. In this part, we created the dataset, as I said, and we converted the sounds features, MFCC features, and load it into dataset file. And here we are reading the dataset, and these are the features. We have the file name, and then we uploaded the file. We uploaded the file name from here, and then we have the Chrome soft features, RMSE, and all these are MFCC features. Now here in this part, we are labeling the data, and we are also deleting the unneeded columns because there are some null values, and also we didn't need the file name. We just need to get this number, which is the label that, or which is the Y coordinate in our training data. Here we are using encoder because we have a different classification. And this is after performing the cleaning and transformation task. As you see, the data here is clear and the number represents the spoken digit. So this one record here, or one row, represent a sound file and labeled as shown here. Now, in this part, we're gonna split the dataset into training and test, and then we normalize the data. And this is the shape of the data. Now we are shuffling the training dataset and test dataset. Why we are doing this? Because it's organized by the number, like 1 1 1 1, all the speakers together, and then 2 and 3. So we need to make sure that the data are distributed evenly. So we shuffle the data before start the training or the test. Now we're creating the model. In this case, we're gonna use Keras neural network. And as you see here, the first layer is 256, then 128, and then 64, then the 10, then 10, because we have 10 digits from 0 to 9. So we are enabling early stopping to make sure that the data is not, or to avoid overfitting. And here is the after plotting the data, and here is the prediction and the accuracy. So right now we have 93% accuracy. This is how we identify the spoken digit using neural network and Keras model. The second problem is the speaker recognition. And basically it's the same model, same training and test data, but we label the data differently. So we label the data, we add one column and we add the first letter of the speaker's name. So J, Jackson, N, Nickel, and etc. We train the data accordingly. Now, as for the results, we get around a 90% accuracy, and it's technically the same. So here 100% accuracy for the three speakers, Jackson, Nickel, and Thu, but it's not the same for some other speakers because we didn't have enough sounds files for them. To summarize the project, we were able to solve two different problems: biometric authentication, speaker voice recognition, as well as spoken digit recognition, by using soundtrack of three speakers in the training and three other speakers, 15 recording each, using MFCC features extraction. Thank you very much.